this video, I'll show you how to solve the ALEKS problem called identifying hydrogen bonding interactions between molecules. You're going to have 3 different molecules here, and you don't need to really know the name of the molecule, but you definitely need to have the Lewis structure of the molecule. It's telling you here that it might give you the formula, it might give you the Lewis structure. Like my first one here, it only gives me the formula. That's not going to be good enough. You definitely need to have the Lewis structure. So if it doesn't provide you with the Lewis structure, either look it up or draw it. Which I'm just going to draw really quick, the Lewis structure for CH3Br. So we're just going to be looking at Lewis structures. Now it's going to ask us 2 different questions about hydrogen bonding, and the first question is asking whether or not it is capable for 2 molecules of this particular compound to hydrogen bond with each other. So that means, can I have one of these molecules hydrogen bonding with a second identical molecule? In order to be able to hydrogen bond with an identical molecule, the molecule needs to have, number 1, either a nitrogen, an oxygen, or a fluorine. It has to have one of those 3 atoms. And then number 2, it needs to have a hydrogen that's on a nitrogen, it needs to have a hydrogen that's on an oxygen, or it needs to have a hydrogen that's on a fluorine. And these can definitely be the same nitrogens. Like it can have a nitrogen that has a hydrogen on it, and that will work perfectly. But in order to meet the criteria, in order to be able to say yes here, the molecule has to have both of these criteria met. So we must have both. An example from number 1, one of these atoms, and then also an example from number 2. So for CH3Br, we do not have a nitrogen or an oxygen or a fluorine, so we could just say right off the bat that this is going to be a huge no. And in fact, we can tell that just by looking at the formula, so actually we didn't even need the Lewis structure for this molecule. I was wrong about that. Second example is ethane. Here's the Lewis structure for ethane. In order for 2 ethane molecules to hydrogen bond with each other, the molecule needs to have a nitrogen, an oxygen, or a fluorine, and this one does not. So this is also going to be a no. And then here's our last one, N-chloromethylamine. In order for this molecule to hydrogen bond with an identical molecule, it needs a nitrogen, oxygen, or fluorine, and we have it. So we have one of the 2 criteria. Now let's look and see if we can find something from this list. Do we have a hydrogen on a nitrogen, a hydrogen on an oxygen, or a hydrogen on a fluorine? We have this hydrogen right here on the nitrogen. So this molecule meets both criteria. It has the nitrogen, and then it also has a hydrogen on that nitrogen, so we're going to say yes. Now, for the next question, the next question is asking, can this molecule hydrogen bond with water? Is it possible for this molecule to hydrogen bond with water? And in order to be able to say yes to this question, the molecule needs to have either a nitrogen, an oxygen, or a fluorine, or it needs to have a hydrogen that's on a nitrogen. And as I'm writing this out, I'm realizing that this is actually pretty redundant. We'll just say it just needs to have a nitrogen, an oxygen, or a fluorine. It doesn't necessarily need to have the correct type of hydrogen. I'm going to leave it like this, but I realize that that's kind of goofy the way I wrote it. So in order to be able to hydrogen bond with water, the molecule just needs to have either a nitrogen, an oxygen, or a fluorine. CH3Br does not have any of those atoms, so that's going to be a no again. In order to hydrogen bond with water, this needs to have a nitrogen, oxygen, or fluorine, and it does not. And then this guy down here, this is a yes. Now, I don't want you to think there's a pattern here. Just because you answer no to the first question doesn't mean you're automatically going to be answering no to the second question. Sometimes this will be a no, and then our second question is going to be a yes. I do want to say, however, though, that if you do answer yes to the first question, you are absolutely going to be answering yes to the second question for sure. But a no to the first question does not guarantee a no to the second question.